Okay, everyone, we're going to start the last talk this morning before the break. And it's really nice to be able to welcome Busra from Turkey, who works at Ericsson, Hungary. She's a Python developer, and she's going to talk about being Pythonic. So let's please welcome her.
Hello, everybody. Can you hear me well? Do I need to be super close to my microphone? That's good. Okay. I am really excited to be here and to share my story with you today. This is my second talk at Pycon. The first one was in Bratislava, where I gave a talk about how to automate big tasks with Ansible in the cloud. And it was quite a technical one, but today I would like to share with you how I met with Python and how I adapted the language into my profession. So I am Busra from Turkey, and I work for Ericsson Hungary in Budapest as a cloud system developer. And currently I work with Python programming, Ansible, and OpenStack. So my talk is going to be another talk about Pythonic thinking. There are several talks on this topic, but this is going to be a bit different one, since I would like to focus on how Python actually works and how we can get the idea of the language itself, rather than have a look how we can write a for loop. So I will share the story of my meeting with Python, and then challenges that I have shortly, and then the use programming paradigms that Python let us do, Python implementation, and the data structures. So my relationship with Python started with out of curiosity. I was doing my bachelor degree, and I was third year of my bachelor degree, and I'm doing some hobby projects outside school. And I wanted to have a script which would tweet for me every day. And why did I needed it? It's a short version of the long story is the following. So I developed a website, and it was listing all the restaurants which was serving a traditional food in Turkey. You know those little cars on the streets, and they have no addresses. So my website was listing all these restaurants, and the users could add restaurants with some contact information, they could vote them, and so on. So I was all alone in this journey, so I did everything on my own, from designing the website, doing the front-end coding, and also the back-end coding. And at the same time, I also needed to promote what I was doing, and also the restaurants that were being added to my website. And so I had no time doing it manually. And those times I was hearing stories about Python and how easy it is to get started, and how it has so many useful libraries that I can use instead of writing long lines of code. So I went with Python 3 because I was just a dummy student, and the last version always sounds catchier than the older ones. And I wrote my script, and it was getting data from a small API of my database, and it was tweeting for me every single day as a cron job. And it was a super exciting thing. So when you are super new in the language and you have your script and it's alive and it's working and it can see every day that it tweets for me, it was really exciting. And of course, you don't want to see how I wrote this code, because it also took me 2 years to feel brave enough and check and refactor it as an experienced Python developer. So I don't want to think here the beautiful better than ugly, but I just want to see what was so attractive or what caught my attention that time. So it was super readable, because at school I learned C, C++, and I was a C# developer that time. And I was doing all the semicolon things and braces, but when I started with Python, it was really easy to read Python code examples, and it gives you a big amount of motivation if you are super new into a language. And the second thing was, it was super portable, because I was coding with C#, and the IDE was everything for me, and also we were able to code only on Windows that time. But Python was everywhere, so I was able to code on Ubuntu and also on Windows, and I was getting started to use Ubuntu that time. So I was able to feel independent enough from the OS and also the IDE. And the last thing was, it was super lightweight, because as a C# developer, I had to install this big .NET framework, I had to install this Visual Studio and create a new project, and it creates a bunch of files, and it's really heavy process. But with Python, I was able to open very simple text editor, and it took only like 5 seconds to be able to write my first hello world. And it was another surprising thing for a very newbie in the language. And the first thing that I was struggling was that how can I manage the packages of the language? Because since I was using Ubuntu at that times, and I was really new into it, but apt-get was solving everything for me. But then, of course, I was reading a lot of Stack Overflow answers, and when I was struggling with the Python libraries, I realized that there's a pip. And I had to understand what is the difference between them, because if you are super new, you don't really know how they work. You just need this package on your computer. So it is good to know what are the differences between them. So I want to mention 3 things that make difference. So pip uses a repository which are hosted by Python Software Foundation. It's a Python package repository, and it has so many packages with different versions. But apt-get is using Ubuntu repositories hosted by Canonical, which means that usually you find only one package, one version of the package, and which is usually the latest one. And the second thing is that apt-get install packages in system-wide, and with the pip you can install packages inside of your virtualenv or a small project. And this is really good to know if you don't want to mess up your old system-wide libraries. And the third thing is maybe very small, but I think it's good to know when you are very new. And apt-get uses a prefix Python with the Python package names, but the VIP you just need to write the Python package name, and it's easy to find. But with apt-get you need to put Python 3 or Python prefix, and those differences was good to know when I was super new. And of course, both package managers solve problem, but you just need to decide which one is good in your case. And the other thing that was struggling for me, the version challenges, because I went with Python 3, and for the first time, it was super weird to have Python 3 and Python 2 at the same time on my computer, because when I'm using C# or the other languages, I never had to think about the versions of language, because the IDE, the language version that I'm using usually is a superset of the previous version, and I didn't really have to think about it. But when I start to work at Ericsson, we are mostly using now Python 2. And I get a point that I really need to handle these different versions in a better way. And this is the time that when I met with virtual environment, and it really rocked my world. So virtual environments are, I'm sure you all know, but as a newbie, it's a super exciting thing. So it solves a very specific problem that it allows you to have different Python projects which has different requirements, usually package dependencies or conflicting packages. And it's an awesome thing, because let's say you have a program, it works as the charm with a library X, and later on you just realize this library has a newer version which would like to try it on. And then you upgrade your library, and then something happened that your program doesn't function well anymore, because something in the API between these versions change, and then your program doesn't use the library correctly anymore. And instead of going through all your code and do the necessary changes, you can easily install a virtual environment, which is this like small isolated part, and then you can try out the libraries there, and you can see whether your code works or not. But for me, the first usage of virtual environment was only to choosing Python interpreter, whether it's going to be Python 2 or Python 3. And now, of course, I'm using for each of my Python projects. And the first line of, Python code of mine was like 7 or 8 lines of code. And there was no main function, there was no function, there was no class at all. And it was super weird, because what I was learning in the school, I first need to write this main function, and I had to have this structure, how it should be. But with Python, I was able to write just as it is, and it was working. So this led to read programming paradigms and what Python actually lets me write my code in which programming paradigms. So there are 4 of them, and the first one is imperative one, which consists of commands, and it runs from very beginning to the end, and it has no function. If we check the example, we have list of numbers here, and we just want to have some of those numbers, and we have no function, we have for loop, and at the end we print the sum of the numbers. And this is the imperative programming paradigm. And the second one is procedural one, where you have your functions, and you can divide your code with functions. And this definitely helps you to perform don't repeat yourself principle. So very same program with the procedural example. We have the function which is doing the adding for me, and then I have the list of numbers, and I'm passing these numbers to the function, and this is totally the same program, but it is written with procedural Python programming paradigm. And the third one is object-oriented one, where we have, where we have data fields and the functions together, and they are treated as objects. So here is the very same program which is written with object-oriented way. So we have the class, and we have our constructor method, and we have the function which does the adding for me. So first I create the object with the list of numbers, and then I can call the function from my object. And the last one is functional one. Of course, the Python is not fully functional language, but it has some functional extensions such as lambda and recursion. And very same program we can write with some functional way. So we can use lambda, and also Python has some functional libraries too that we can use, and our code would look more functional. And you can write those programming paradigms, which one you want to. And I think also Pythonic, if you are talking about Pythonic thinking, you should really consider which programming paradigms you are using, and I think that's why we have different views on how the code should be more Pythonic. And so far what I was talking was C Python, and when I realized that C Python, so what is this C, like before this Python name, because I was already struggling with versions and the libraries, and now there is also something called implementation. So I also had to understand what this implementation means in Python case. So implementations are basically should be taken to mean an environment or program that lets you run your Python code. And there are several implementations of Python. CPython is the traditional one that we are using usually. And Jython is written for Java virtual machine. And there is IronPython for .NET, and there is also MicroPython that we have been talking a lot these days. And so whenever they need to make Python work somewhere else, or they need to put some other features into Python, it becomes a new implementation. And also, when I realized I realized that also Python works with virtual machines. So I knew that Java and C# was using virtual machine. They are high-level languages, and I didn't know that Python is also using virtual machines. And this was also useful information to know that how it is compiled, because C and C++ kind of languages are compiled to a machine code, then they execute it. But these kind of high-level languages they have the virtual machines, they are compiled to an intermediate code, then they execute with the virtual machine. And then I realized that Python is also using the virtual machine, since also it has implementation. So although those languages had this virtual machine in common, I was not able to compare them because C# or Java was a static language and Python was not. So Python is a dynamic language, and I had to understand this idea, what this dynamic language means. And then I easily find a way to understand with these 3 things. So first of all, there is no type safety, and this allows you to do some runtime changes. And also they use the memory in a different way. So I had to understand how Python is using the memory, and then and everything is in object in Python. So everything is created as object. So let's say you have a program, and you have a decimal number for this program, and in the static type of language, you need to create a variable, and you need to say what this variable is going to take place, or how much memory is going to consume in your memory. And then when you say it's going to be float, so it's your program is going to allocate a memory for that. And after that, if you need to decide changes, or if you assign a bigger number to your variable, your program is going to crash. But in Python or dynamic type of languages, this is not the case. So when you create a variable, when you assign a number, then later on you can easily assign a bigger number, and this is going to work as it expected, since it is treated as an object. So, and also I have to say as well that in Python, values carries the type, so not the variables. Yeah, okay, sorry. So the other thing that I was really lost in data structures, and of course Python also has these traditional data types, which are string, list, and integers, but it also has other data structures which deals with a collection of data. So, and those are the list, tuple, sets, and dictionaries. And usually, I know that when we need the collections, we always go with the list, because this solves for us everything. But I think when you really know what is what, I think it also makes your code more efficient. So that's why I wanted to understand what are the differences between them. So lists are immutable objects, which means it can be changed. And they can contain different data types. And it has many functions for appending, extending, and so on. But the tuples also has the similarity with list, but they are mutable objects, so that it cannot be changed. And in the tuple, they don't have the methods as much as the list. So you cannot extend the tuple because it doesn't have append method or extend method, or you cannot pop an element from a tuple, but you can definitely get an element from a tuple. And I think it is good to know that if you need a collection of data which you will use only for iteration, I think it's better to use tuple than list, because they are faster than the list. And there is also set, which you cannot have duplicated elements inside of set. And it also allows you some special functions which are union, intersection, or difference, like a mathematics. And the last data structure was dict, which is my favorite dictionaries. You can have key-value pairs, and the keys are unique, and the values can be everything. And this is usually useful when you don't really want to create a class or object. You can easily perform your objects with the dictionaries. And I think you really need to understand what are the differences between collections if you want your code to write more efficiently. And since I'm in the data structures, I also had to mention about list comprehension. So Python allows you to have create lists in a more natural or an easy way. And let's give it an example. So this is a Python code, and and probably it's a Python, but it's thinking in another language, because I have two lists, number of lists, and I would like to subtract the elements from these two lists. So therefore, I have two fors nested, and I go iterate for each list, and I would like to subtract the elements from each other, and at the end, I would like to have a list. So, and if we want to write this a bit better way, we can have these two lists again, and then we have the lists created, and then we can write the for loops in a more Pythonic way, and we can also use the list method, which is append. We can easily subtract the numbers while we are appending. And this is more Pythonic because, as you see, we don't need an index, we don't need a range to go to do the for loops itself. But if you do it with the list comprehension, it would look just a one-line code. So we have these two lists again, but we can write these for loops in only one line. And it looks super neat and super beautiful. And if you really use it wisely inside of your code, I think it really helps you to have more readable code, and I know there are some cases that if you use it over, and this is going to make your code really unreadable. And this part of my talk, I would like to talk about things that made my life easier. And the first credit goes to Interactive Shell. And actually, I was thinking whether I should put this here or not, since it's a very basic level. But I was like, the first friend of my, since I met with Python, my best friend was Interactive Shell, and I had to give some credits how I use it. So it was super exciting or surprising to have just a shell, something alive that you can try some things on. So whenever I need that how something works, I just, instead of writing up a file, I just fire up an interactive shell and I can see which function returns what. So I usually don't remember the range, which numbers are going to be included, and still I'm always checking an interactive shell. And also I use dir and help if I want to know how my objects or function is. So especially help is, it opens and documentation inside of your shell, and I think it is quite quicker way to open the documentation instead of going to the web browser and open what it says. And the last thing that I use a lot is the type, especially when I'm trying the new libraries and I don't know what the functions are returning and I don't know how to use them. I usually use the type and pass the object. It gives me the data type of the object that I'm using. And the other things that was surprising and interesting was PEP. There were some times that I realized when you are very new, your code looks really easy, straightforward, but at the same time very ugly. And this is the time when PEP comes into the picture. And I had to understand how they do these PEP documentary things. And I was really fascinated to see that the document what describes what PEP is also a PEP, which is PEP1, and it really makes sense. And of course, I started with PEP 8, and so far I have been engaging with PEP 8, PEP 20, and PEP 3099. And the PEP 20, I am sure you all know this end of Python, and it's always there whenever you need it. And I think it is really the key PEP that allows you to understand what Pythonic thinking and how to write your code more Pythonic in a more poetic and philosophic way. And maybe some of you have not heard about PEP 3099, and I just wanted to give some credit to it. And it describes things that will not change in Python 3000. And I think it's really fun, and it is interesting to read, so I would definitely recommend you to have a look. And before I go, I would like to mention that with the tools that I'm using. So the Python is the first one that it's a Python program that gives you a lot about your code, and it checks your code as a coding standards. And I know there are several tools for this topic, for this purpose, but Python is quite talkative. That's why I like that. And it gives you a big output, and it also scores your code. And when you are new and you are trying things out, it's really good to see some scores, and you can try it out your Python program and over. And I use pipfreeze for virtual environments, and as I'm using a lot, so I need to know which packages are installed in my environment. So pipfreeze is always there, and it's so helpful. And as an editor, I'm using PyCharm and Vim. And if I want to have some user interface, I'm using PyCharm, but if I'm working on server side, I use Vim. And both editors are capable of having some plugins that can check your code style, and even while you are writing them. And I think these plugins are quite useful. And that's it. That's all I wanted to share with you today. And I hope you enjoyed and you had some takeaways. And if you have any questions, I can take them now. And if not, I will be here alone all day, so we can have a chat. And thank you very much.
Thank you very much. Thank you very much, Busra. So we have some time for questions. If people want to queue up in front of the mic for Busra.
Yes, Busra, thank you very much for the talk.
Thank you.
I think your love for Python came out quite clearly. You're obviously working in Hungary and you're Turkish.
Yeah.
I was just wondering, does Hungary and Turkey love Python? The say the way the UK and Europe. What's the
Does
insight?
Hungary love Python?
Yes. Is it used in schools? Is it in universities? In
Yeah,
Hungary
I don't
and
know
Turkey?
about universities and schools, but in Hungary we also have Python community that we hold meetings every month as Budapest.py, and there I can see really newcomer people and so many girls and also very newbie people, and we had some talks there to share Python to be more common. And I think this is one community that I can say, or some organized, that makes Python to be more loud. And yeah, but I don't know. I don't know about universities and the schools.
And
But
Turkey?
we have community.
In Turkey as well? Is Turkey in love with
In
Python?
Turkey? Actually, I'm living in Hungary for 2 years, and before that I learned like 1 year Python in Turkey. But in my university, we mostly use C, C++, and C#. And as I said, I learned Python as like really lots of curiosity, and like 2 years ago when I was there, I didn't really see any Python around, and I cannot really say that this is really common in Turkey, or as far as I know. Yeah, thank you.
I've got a question myself if no one else has one. So you learned C and C++ before learning Python.
Yeah.
Do you think that had a positive or a negative effect on you as a Python programmer now, as opposed to if you just learned Python immediately?
I think learning C at the very first place is a struggle. I would definitely would have loved to start with Python and see more than syntax than how I can actually write the loop and how I can understand how a programming language works. And for me, I think it would have been like much better if I started directly with Python. And I think that's why I feel so happy to see now there are MicroPython and there are these small children that they are engaging with Python first. And I think it's going to really make some difference. Yeah. Thank you very much, Nan.
Let's give Busra one last thanks.